Hello, this is the 2009 paper. Okay, let's go. When I've got a question about a two-way table, I'm looking for either rows or columns where there is just one piece of information missing. So, for example, just here, I've got two pieces of information, but I've got one missing. And this allows me to work out what that missing value is. So I will do the total, 37, take away 15, which of course leaves me with 22, which I can fill in here. And since I've done that, I've now created a row where there is just one piece of information missing, and that's the total. So I need to add up the values so far. 22 plus 8 plus 16. 2 add 8 is 10, 6 is 1, 16 rather. 2 and 1 is 4, so this is a total of 46, and that's absolutely correct because I can see that these two would add up to 100. I've got another column here where there's just one piece of information missing, so I just have to add up those values. That makes 30. I've got a row here with just one piece of information. That's the total, 54. And this, and this add up to it. So I'm going to first of all add up 15 and 14 to make 29, and then I'm going to take that away from the total. So that's 54, take away 29, 4 take away 9 I can't do, so I'll borrow one from next door. 14 take away 9 is 5, 4 take away 2 is 2, so that's 25, and that goes in here. Oops. And then all I need to do is work out from here what the total is down here. So 25 add 8 is of course 33. And I'm just going to double check by looking along this row. 37 add 33 is 70, add 30 does make 100. Excellent. So now on to part B. Write down the probability that this child walked to school that day. Well, I can see that the walkers were a total of 37. Out of a total of 100 children. So that's 37 out of 100. And I must remember to write a probability as a fraction. Done.
Okay, I'm going to go print.
Okay, this question says simplify. So I'm looking for any terms that are like, so they're the same kind of term. For example, 4x and minus 2x are like terms, and 3y and 5y are like terms, and I just have to gather those together. The important thing to recognise here is that it's 4x minus 2x. So that minus goes with the 2x, it doesn't go with the 3y. So it's 4x minus 2x, which of course leaves 2x, and then I've got 3y plus 5y, which makes positive 8y. So in total I've got 2x plus 8y. Compasses cost c pence each, rulers cost r pence each. Write down an expression for the total cost in pence of 2 compasses and 4 rulers. So that's 2 lots of c pence, because each compass costs c pence, and it's 4 lots of r pence for 4 rulers. But of course we don't use the times sign when we're dealing with algebra, because it looks like the letter x. So we just write 2c plus 4r, and that's the answer. It should have been written there. Okay, done. Right, question 3. Complete a table of values for y is equal to 4x minus 3. So this means to get each y value, I'm going to multiply my x value by 4 and then take away 3. So if I start here with x is equal to 1, I get 4 times 1. Oops. I get, I'll just do it up here, 4 lots of 1. And then I'm going to take away 3. So 4 lots of 1 is obviously 4, then take away 3 is 1. Then I'm going to do when x is equal to 2. So this time I'm going to do 4 times 2, and then take away 3. So I've got 4 times 2 is 8, take away 3 is 5. That goes in there. Now, this one is slightly more difficult when I'm dealing with minus 1. So I'm going to do 4 lots of minus 1, and then I'm going to take away 3. Well, 4 times minus 1 is minus 4, and then take away 3 is minus 7. Now I'm just going to double check. There should be some kind of pattern here, and hopefully I can see that each time it's going down by 4. Let's just check this one. -3, take away 4 is -7. Yes, that's correct. And of course it should have gone up or down by 4 each time because of that 4x. Now it says on the grid, draw the graph of y is equal to 4x minus 3. All I have to do now is take those coordinates from the table of values. So what I've got here is 3, 9. So I'll plot that first. 3, 9 goes there. 2, 5 goes there. 1, 1 goes there. It's certainly looking good at the moment. 0, -3 there. -1, -7 there. And -2, -11 there. They all look good. They're all in a nice straight line. And then I should have a ruler at this point and should draw that in. Done. Okay, question 4. P is equal to 4k minus 10 and P is equal to 50. Work out the value of K. So if I just substitute those values in, I've got P, which is 50, is equal to 4k minus 10. Now I want to find out what K is, so I need to undo what's happened to it. At the moment, K has been multiplied by 4 and then I've taken away 10, and I need to undo that taking away 10. So I'm going to add 10. I'm going to do that to both sides. When I do that to the right hand side, I get rid of this bit, the minus 10. So now I'm just left with 4k. But because the equal sign is like a set of scales, and they must balance exactly, if I've added 10 to the right hand side, then I must also add 10 to the left hand side. So that now gives me 60. So 60 is equal to 4 times k. Now I don't want k times by 4, so I undo that by dividing by 4. When I divide this side by 4, I undo the fact that it was multiplied by 4, so now I am just left with k. But if I divided the right hand side by 4, I must also divide the left hand side by 4, and 60 divided by 4 equals 15. So I found out that when P is equal to 50, K must be equal to 15. In the second part, y is equal to 4n minus 3d, when n is equal to 2 and d is equal to 5. So lots of people worked out that 4 times n was 4 times 2, that equals 8. And lots of people worked out that 3 times d was 3 times 5, which equals 15. And if you had just written those simple calculations down, you would have got a mark, even if you'd not worked out the final answer. Now this first one was 4n, and this second one was 3d, but I must remember that it says 4n minus 3d. So I'm taking my 4n value, which was 8, and I am taking away my 3d value, which was 15. And of course 8 take away 15 is equal to minus 7. Done. Okay, question 5. This A part I can't really do because I would need a piece of tracing paper, but the B part is quite nice and easy to look at. It says, describe fully the single transformation that maps shape P onto shape Q. And so it uses this word transformation. So there are 4 different transformations I could choose from. Reflection, well, it doesn't look like a flip to me. Rotation, no, it doesn't look like it's turned. Enlargement, it certainly hasn't got bigger. And translation, which is a slide, and that's exactly what it is. It's a translation. So that's the first mark, is to describe what type of transformation it is. But I also need to describe how it has been translated. And given that it's 2 marks, I need to include that vector. So you will remember, hopefully, that we describe how far it's gone across as the top number and how far it's gone up or down. We must remember that on the across side, going to the right is a positive number, but going to the left is a negative number. And on the vertical bit, going up would be a positive number and going down would be a negative number. So if I look from P to Q, it's gone across 1, 2, 3, and 1 down. So I'm going from one point on P to its corresponding point on Q. And I see it's gone 3 to the right and 1 down. So that is 3 and minus 1. So I need to get 2 pieces of information to get those 2 marks. Okay. Okay, question 6. It says the diagram shows a rectangle and all the measurements are in centimetres. Explain why 4x plus 1 is equal to 2x plus 12. Well, here you just had to recognise that that was this side, 4x plus 1, and this side, 2x plus 12. And of course they're equal. Oops. Because opposite sides of a rectangle are equal in length. Then it says solve 4x plus 1 is equal to 2x plus 12. So it's looking for a value of x that makes this correct. There are lots and lots of different ways that we could solve this. One, if you have literally no idea, would be just to chuck in a couple of values. Let's say x is equal to 2. Does that make it right? Well, 4x would be 8 plus 1 would make this 9. And on the other side, 2x would make 4 plus 12 would make 14. No, it's definitely not that. So it's not x is equal to 2. I wonder, is it x is equal to 3? And you could try lots of them if you had enough time, particularly at the end of the exam, and just try and find the value that it was equal to. However, a better way of doing it would be to use the balance method, which says 4x plus 1 is equal to 2x plus 12, and it's like a set of scales. I've got most x's on the left-hand side. I've got 4x's there and only 2x's there. So what I want to do is get my x's onto this side and my numbers onto this side. So on the left-hand side, I want these x's, these 4x's, but I don't want this 1. So what I'm going to do is I'm going to get rid of that 1. So on this side, it gets rid of the plus 1, it just leaves me with 4x. But if I took it 1 away from the left-hand side, I must also take it away from the right-hand side, and it's going to come off there because it's just a number, so I need to take it away from the numbers. So then I get 2x plus 11. So at this stage, on my left-hand side, I've just got x's, brilliant. On my right-hand side, I just want numbers, so I don't want this stuff. So to get rid of it, I'm going to take away 2x. On the right-hand side, it gets rid of the 2x, and so it just leaves me with 11. But I must remember to also do it to the left-hand side, so I get 2x is equal to 11. And then I don't want x times by 2, so I'm going to undo that by dividing by 2. When I divide this by 2, I undo the fact that it was multiplied by 2, so it just leaves me with x. But if I divided the left-hand side by 2, I must also divide the right-hand side by 2. So x is equal to 6.5 centimetres. And now it says use your answer to part B to work out the perimeter of the rectangle. Even if you'd got this answer wrong, as long as they see that you've used your answer, you would get at least some of those marks. So if I think that x is equal to 6.5, that means that that side there is 6.5, that side there is 6.5. Then I've got 4 lots of 6.5. Well, I know that 2 lots of 6.5, in fact, I'll do this length first. 2 lots of 6.5 is 11, plus 12 is 23. And of course, because I know that the opposite side is going to be the same, I also know that this is 23. So now I can just add those up, because that's what perimeter is. 23, add 23, add 6.5, add 6.5. I know that these two make 46, and I know that these two make 11, so I can add them together to make 57 centimetres. Done. Okay, I'm moving straight on to question 8 now, because it's a nice link to solving equations. 2x squared is equal to 72, and it says find a value of x. Essentially this is saying, again, solve this equation. So I've got 2 times by x squared is equal to 72. So if I think about what's happened to x here, first of all it's been squared and then it's been multiplied by 2, and I need to undo that last thing that was happened first. So if I divide both sides by 2, I get 1x squared is equal to 36, and then I just need to take the square root to find that x must be equal to 6. Done. Express 72 as a product of its prime factors. Well, this is where you start with 72 and you think about factor pairs that go together to make 72. So I'm going to say that's 2 times 36, and because 2 is a prime number I stop there. And then 36 is 6 times 6. Neither of those are prime numbers, so I need to carry them both on. 6 is 2 times 3. They're both prime numbers, so I stop there. And 6 is 2 times 3, and they're both prime numbers, so I stop there. So now I can just take these prime numbers and write 72 as a product of them. And product means times, so this is 72 is equal to 2 times 2 times 2 times 3 times 3, which could also be written as 2 cubed, because it's been multiplied by itself 3 times here, times by 3 squared. Done. I've jumped straight to question 14 now, because I think this is one that really you could do. The question says, work out an estimate for the value of 6.8 times 191 divided by 0.051. When it uses this word estimate, it means that it wants you to round these numbers just to one significant figure. So 6.8, we're just interested in the 6 part, and we decide whether it's going to be a 6 or it's going to be a 7. So we look at the next digit. Because this is 5 or above, it means we round it up to a 7. So that first number is 7. Then the second number, 191, we're just interested in the first digit, the 1 or the 100. Now it's either 100 or it's 200. We look at the next digit, which because it's 5 or above means that we're rounding up to 200. So it's 7 times 200. And we're dividing by, now we're only interested in the 0.05, that's the first significant digit. So it's either 0.05 or it's 0.06. We look at the next digit, which tells us that we round down to 0.05. Now that will get you 1 mark just for writing that. Then we know that 7 times by 200 is obviously 1,400. And we're dividing by 0.05. Now it's worth recognising that 0.05 is the same as 1/20th. And if we're dividing by 1/20th, so I've got that's the same as 1,400 times by that fraction flipped over, 20 over 1, or just 20. So 1,400 times by 2 gives me 2,800, but I wasn't multiplying by 2, I was multiplying by 20. So this is your answer. I'm skipping to question 16 here, another one that I think that you can do. Remember, factorise means put the brackets back in. So we need to look at these terms and think, well, what can I take out of both terms rather? I'm dealing with 4 and 6 as numbers. I know that 2 is a factor of both of those. And if I look at the algebraic bits, I've got x squared, which is x times x, and I've got xy, which is x times y, which means that x is in both of those. So I'm going to take the x out. And then I think to myself, okay, 2x times by what would make 4x squared? Well, if I multiply by 2, I'd get the 4x, but I need to get 4x squared, so it needs to multiply by another x. And 2x times by what would make 6xy? Well, I know that I've got to multiply by 3 to get the 6, but so far I've got 6x, and I need to make 6xy, so it's there. Because it's a negative up there, I need to make sure it's a negative in here, and that's done. Now you need to recognise that this is a type of quadratic that you get when you have two sets of brackets. And we did lots and lots of work on expanding and factorising. Now we know that x goes in here, and we need two numbers that multiply together to make -6, but add together to make +5. And I know that that must be +6 and -1. When I multiply these two numbers, 6 times -1, I get -6. But when I add these two numbers, I get +5. And that's it, done. So factorise means put the brackets back in. Question 18, I was so pleased that some of you tried this. Work out the size of angle AOD. If you trace out the journey from A to O to D, you can see that this is the angle it's after. And I was really pleased that loads of you saw that there was a triangle here, and you took a bit of a guess that this was a right angle, and you were absolutely right to. So we had 36, we had 90, which made 126, and then we had to work out, because angles in a triangle add up to 180, we took away 126 to find that the answer was 54. And what was really important about this question is you could hazard a guess with it. It was only 2 marks, and they didn't ask you the reason why, so almost you didn't have to know why. You did just have to hazard a guess, and I was really pleased that lots of you did that. Well done. Another question that I know I've never looked at with you, I've never ever looked at these types of questions, simultaneous questions. However, this part in particular was a 1-mark question, and it said, use the diagram to solve the simultaneous equations. And it told you that the graphs were already drawn. So we can assume that these two lines are those graphs. And it says use the diagram to solve the simultaneous equation. And then if we look here where they want the answer, there's an x value and a y value. And because it's 1 mark, you can hazard a guess at this one. Now, I think it's quite straightforward that there is one point on this diagram that is important. And the one point is the place that those two graphs cross. And I think if I had to hazard a guess, I could say, okay, well, if they want an x value and they want a y value, I'm going to take it from that point. The x value is obviously 2, because the point is 2 across, and the y value is obviously 3. If I had to write this as a coordinate, this point would be 2, 3. So the x value is 2, and the y value is 3. And sometimes you have to look at the questions and just use your brain a bit and think, if it's only 1 mark, it's probably quite straightforward. I'd like to look at question 23 because, just again, I think this is a classic GCSE question. It's quite easy to get good marks here, or at least these first 2 marks. In a game of chess, a player can either win, draw or lose. It is certain that they will either win, they will lose, or they will draw. And when something is certain, it means that the probabilities add up to 1. It says the probability that Vishy wins any game of chess is 0.5. That's shown here. The probability that Vishy draws any game of chess is 0.3. That's there. Vishy plays 2 games of chess. That is why there is 1 set of branches here for the first game, and then a second set of branches here, because this is the second game, and it depends on how he did in the first game. And for 2 marks, all you have to do is complete the tree diagram, and it's as simple as this. If it was 0.5 of winning, 0.3 of drawing, that means so far I've got to 0.8, means that the probability of him losing was 0.2. And then I just need to repeat those probabilities for the second game. There is still a 0.5 probability that he will win, still a 0.3 probability that he will draw, and still a 0.2 probability that he will lose, and again. And this comes up year after year after year, and it is literally as simple as that. Oops. Just as a point of interest, what this tree diagram shows is Vishy wins the first game, in the second game, he's still got an opportunity of winning, drawing or losing. If he draws in the first game, in the second game he's still got the possibility of winning, drawing or losing. And if he loses in the first game, he's still got a probability of winning, drawing or losing in that second game. So that's how tree diagrams work. Now there will be a question after it, but that was two relatively simple marks.